working as a solution architect. I do have overall 17 years of IT experience. So out of which from almost for the past 7 years, I'm engaged in cloud migrations, but for the past 12 years, I engaged in various migrations like from on-premises servers to various platforms, for example, some Solaris, and then so on-premises to the virtual cloud. I mean, so AX, Linux, a lot of migrations I have been involved in. So here, as part of today, I know it's Saturday, so excuse me, I'm not going to take much time. So let's try to finish my session as well as possible. So let me share my screen, and we will slowly start about, and mainly we are going to focus about the demo, what we are going to do. For example, the Fargate is the one which are going to see. So what is Fargate and why we are using, and what is the use case and how we are going to implement. So we are going to split up into a multiple segment, and we're going to see, and it's a complete hands-on. So we are going to see the complete setup, and we're going to split up into 3 categories, and I'm going to see the results in all the 3 categories. So before I proceed further, is my voice is clear?
Yes, it's clear.
Great. Okay, let me share my screen. So good evening, everyone. So very recently, I have been recognized by Amazon as AWS community builder. I'm actively interacting with the college students, and mostly from the rural areas, and so as well as city. I do conduct guest lectures and webinars to the college students, and I have been selected for operations category. Here, let's start from some basic ideas. So it will give you, I mean, I'm not sure how many of you already have the cloud background. I hope so. Anyway, so that's why I'm going to start from some basic concepts here. So if you see the cloud model, we do have on-premises from networking, storage, servers, virtualization, operating system, middleware, runtime, data application, which means in all the things we have to take care. We have to recruit resource for networking. We have to recruit resource for storage. In each category, you have to recruit resource as a company owner or as an employer. So you have to deploy the resource on each category, and you need specialists on each category for your application to up and run. So that is on premises. You have a dedicated land, and you have to buy the land, and you have to set up everything. Or maybe you can rent out. So that's a different story. But here, typical on-premises setup is actually like each stages you have to invest. So that's where infrastructure as a service has arisen almost a decade ago. But it's very famous, I can say, for the past 9 years, maybe more than that. So infrastructure as a service, we are going to see a couple of services from this IaaS as well. So let's take an example as AWS. Very famous service from AWS is EC2, Elastic Compute, right? So virtual machine. If you see, the 4 things are completely managed by AWS. So networking, storage, servers, and virtualizations. We don't really need to worry about all these 4 categories. So that AWS will take care of it. We just need to pick up the operating system and spin up the EC2 instance. On top of it, whatever the components you need to install, for example, WebSphere application server or Tomcat or whatever it may be, you have to do install manually. And the runtime Java, you need to install manually and take care. Data as well as the application. So coding part and everything you have to take care. So that comes under infrastructure as a service. Let's go to platform as a service. Even we don't really need to worry about operating system, middleware, runtime. Everything is managed by cloud providers like AWS, Azure, or Google, Alibaba, of course. So we have to focus only on data and application. So what is the best example? ECS, Elastic Container Service, is the best example. Software as a service. Software as a service, everything is bundled. You will get only the software. The best example for SaaS is Gmail. So we are using Gmail as a service, right? So we're just logging in, we are sending email. We are not doing anything. So everything is handled by Google. So that's why you can easily able to send email and receive email. So that's the best example for SaaS. Let's move to the next. Serverless. Let's discuss about serverless. So everyone is talking about serverless, so which means there is no server at all. So even in ECS category, we are just going to install the application. So which means the server is not required for that. No, we need a server, but everything is managed by the cloud providers. So in the background, they take care of provisioning the instances, they're provisioning, take care of everything. So runtimes, middleware, operating system, virtualization, servers, storage, networking, everything. The cloud provider will take care of it. So we don't really, as an application user, as a consumer, we don't really need to worry about it. Or as the employers, we don't really need to recruit any resources for these components. So that is what serverless. So they do have a server, they spin up server. It's a lightweight operating system. They do have very limited dependency file, which is required to run the application. That's it. But definitely it needs a server, but that's completely managed by cloud provider. So that is what the serverless is. So we are going to discuss mainly about AWS Fargate. And AWS Fargate, we can say it's a serverless as well as container. So we are talking about Elastic Container Service so far, right? So initially Elastic Container Service used to spin up in EC2 instances. So we create a Docker image and that will be deployed in the EC2 instances that we have to manually take care of the EC2 instances. But here in Fargate, Fargate is a technology. So we can even say it's a serverless. We are going to do pay as you go. It's completely managed, a redundant service. It's completely managed by AWS service. It's one of the so much powerful service, I can say. We are going to see a couple of other services as well. I have prepared one architecture diagram, which I'm going to show you. And as per the architecture diagram, we are going to implement the demo. So Elastic Container Registry. So what is this? So we do have a Docker Hub, right? So Docker Hub, we do have a lot of images. It's a public repository. You are creating your application as an image, and that image you need to place into some place, right? So that is called a container registry. So it's an Amazon provided container registry. If it is Docker provided, then it's called Docker Hub. So GCR is similar like Docker Hub. Maybe you can just remember like that. So this is the architecture which we are going to discuss today. Okay. So AWS general users. Those who are going to hit the URL, maybe all of you are general users in this case. And the first part is, as an admin, I'm going to create a Docker image. I'm going to create a EC2 instance. And I'm going to build, create and push the Docker image to Elastic Container Registry. So the part number one, I'm going to create an EC2 instance. I'm going to install the Docker, and we're going to create some simple image like hello world. And the scenario one is to see whether that application is working fine or not. if you see, it's AWS cloud, and within the VPC, we do have two public subnet 1 and subnet 2. Since you have two subnet, it's a highly available, right? 1, 2. Even though if one public subnet goes down, other public subnet, the instance which is running here will take care of it. And AWS Fargate, Elastic Container Registry, you don't really need to worry about highly available because it's a AWS managed service. It's already highly available. It's a redundant. So even though any some the availability zone 1 goes down, Amazon themselves, the product itself will take care of that. So the product will not go down. By default, the services like Fargate, application load balancer and container registry. So these are all Amazon managed services. It's already highly available. So we don't. So there is no manual intervention required. So we don't really need to do any configurations for the highly available. So just for information. Now let's focus on the step number 1. Okay. So create the EC2 instance, install the Docker, create the image, and push the image to Elastic Container Registry. I hope you all can able to see my screen. In case if you are not able to see my screen, please let me know. Let's launch a new instance. I can name this as the same name. So maybe a multiple cloud for you demo 1. Okay. Amazon Linux. So AWS, they do have a lot of mission images. We do have a lot of instance types. Okay. In this demo, we are just going to use a basic mission. In this case, it's a free tier eligible Amazon Linux to Army. That is the one which I'm going to use for Army, and the instance type, what I'm going to use T2.micro. So this is also free tier eligible. If you see, it's just 1 CPU and 1 GB memory. It's a very simple mission. And if you come down, I do already have a key pair. So I'm going to use the same key pair here. Security group, maybe I can use the existing security group. Let me use a launch wizard 29. I'll show you that. So I have already created a security group. So nothing. So we have given a port number 80 and port number 22 on this security group. The reason is, let me show you here. So this is the mission which we created now. And we do have a public API assigned and private API assigned. If you go to security, this is the security group which we mapped. And the security group, if you see, the port number 22 is allowed because I'm going to use the putty to connect this machine. And I'm going to use port number 80 to access the Docker image. let's go back to the architecture diagram. So as admin, if I install the Docker image to access the URL, I need a port number 80 because anyway, it's going via internet, right? So the port number 80 should open, and to access the EC2 machine from my laptop, I'm going to use putty, and it requires the port number 22 to open SSH port. So that is the reason. And now the instance is up and running. So let's take the public IP. I'm sharing my putty session as well. I hope you can able to see now. So let me know if you cannot able to see. I'm just going to map the key pair which I already created for this EC2. So whenever you create first time, of course, it will going to ask you, or else when you create instance, you can create one new. So if you see, this is the public IP which is created as part of this mission. 35.88.245.207. It's a default user EC2-user, and I have already mapped my key here, whatever I have created, and I'm just going to log it now. So I have logged into the machine, and now as per the architecture diagram, let's install Docker and other steps. So don't worry, I'm going to create a detailed blog in Amazon portal, and I'm going to share in my LinkedIn. So what are the commands which I'm going to use? I'm going to detail in complete detail which I'm going to mention. So the step number 1, I'm going to install the Docker here. So sudo yum update y, it's just to update. And let's install the Docker now. It requires the Linux extras and Docker. It's installing the Docker image now. Docker software into this EC2 machine. So just going back to the architecture diagram, see here. So the EC2 instance we have created now, and I'm installing the Docker in the EC2 machine. Done. If you see that the installation is completed, let's go back to the next step. Once the installation is completed, we have to start the Docker, sudo service docker start, and sudo system ctl enable Docker. Even though if you do restart, the Docker will come up automatically now. And we are using the user ID called EC2-user, right? So we are adding the EC2-user ID into the group called the Docker. So now we completed the Docker installation, and once the Docker installation is completed, now let's see Docker info. Now everything is good. I have to log out and log in, or else sometimes it will not work properly. Sudo, every time or else we need to enter sudo. So that is the touch the Docker file, and in the Docker file we are going to add a couple of files. So let's see. So what we are going to do now is, now we have installed the Docker here, and we are going to create an image. For example, let's take consider the developer is developing the code, and they have to containerize the code. That is the reason we are using the product called Docker. So before we continue further, maybe we can quickly see what is Docker. So Docker, the official definition is it's an open platform for developing, shipping, and running application. Okay. For the Docker image, so what is Docker image? In the Docker software, we are creating something called a Docker image. So what are we creating? So Docker image, it's a read-only template with instructions for creating Docker container. So the software, whatever the language we are going to use, we are going to use a kind of, so mostly the heavyweight applications, we will not go into container. So the lightweight applications only, we mostly prefer container, especially the service related applications for the cloud migration. For that, we really use not a heavyweight of monolithic. Definitely, we will not prefer container and all, but other than monolithic, the microservices, we can definitely prefer containers. The reason is you can split one monolithic application into multiple applications here. So even though if one application is down, it will not create impact for the whole application. So for example, let's consider one application, you're splitting into 5 small applications. So which means 4 applications is running and one is down, then you do have impact only on the one smaller portion. Your entire application is not down. So very smaller portion is down. So that is the reason. So nowadays, so organizations are preferring containers more. It's a microservice architecture mainly. Let's go back to architecture. We are in progress of creating the image. And if you see, these are the lines which are going to create a Docker file. It shows that we are going to use Ubuntu as the Linux, and we are going to install the dependencies file and going to install Apache web server. In the Apache web server, we can just going to type, create some hello world program. That's it. Let's see, multi-cloud for you. Okay. And we are saving here to create a Docker image. And next step, what we're going to use, now the Docker file is ready. And what we're going to do is we're just going to build it. See, from Ubuntu, literally installing the operating system, very lightweight operating system. On top of it, it installing very limited libraries and dependencies, which means you can consider one micro VM is getting ready now. So the EC2, whatever we created, maybe you can consider is a huge virtual machine. And here inside the Docker, what you're creating now, it's a micro virtual machine. Just for remembrance, you can use this terminologies. Okay, see, it's the build is completed now. The next step is let's do a couple of other filters and repository configurations and the port expose. So what is the port number which you're going to use? I'm just going to use port number 80. See the container port number 80, and as well as I'm going to use the port number 80 to access from my browser. It's a public subnet, and I do have the complete access to access this EC2 machine as well as the Docker, and I do have already the port number opened for 80. Correct? Now let's go back to console. Now what we did is we installed Docker and we created image, and we do have the public IP or public DNS. Let's copy anyone. Go here and type it. Of course, by default, it is going to take http:// type it. Hello multi-cloud for you. So the result is coming from where? The Docker file is what we created, and the Docker file has the hello world program. And go back to architecture diagram, we can able to access the image, Docker image, whatever we created. So typically it's a small hello world application, but in a larger world, so whatever the heavy applications the developers are creating, it will be deployed here. And it's one of the way to test whether the application is working fine or not. Now the next step, we have to move the image, whatever we created from here to Elastic Container Registry. Go back to console. Go here, type ECR, Elastic Container Registry. As I already mentioned, it's a container registry where similar to Docker Hub, which whatever the image is, Docker image you are creating, you are securely going to store here. Okay, this is the product completely managed by AWS. It's a highly available, redundant, so one of the fantastic product. Whatever the image you are sending here, it's so the encryption is enabled by default at rest, so it's more secure. Let's create one more. I mean, I have already created one for my testing, but maybe I can quickly delete that. Let's create one. Maybe we can leave it as default and go back and take the choose a name. Maybe we can say hello-multicloud 4 as a repository name. So there is two ways. So the one way is we can create Elastic Container Registry from console, or the other way we can create from our EC2 instance. So let's see, I mean, how to create from EC2 instance. So to create EC2 Elastic Container Registry from EC2, so go back here. So EC2 is sitting inside your public subnet, and Elastic Container Registry will be created within your cloud, but it's completely managed by AWS. So which I mean, the thing is, you're not going to create in within this availability zone 1 or 2 or something. It's not like that. So you're going to create and AWS is going to manage. It's a highly available. I'm repeating the highly available word again and again. The reason is we should understand the importance of the product. It's really the positive object or positive point which we need to consider ECR and Fargate. So even though everything is within AWS cloud, from EC2, if we need to communicate with this guy, the communication should be enabled. So for that, we are going to use something called IAM role. We have to enable role or attach the role here by using that IAM, and so that the EC2 will have the complete privilege to create the ECR here. So let's go back to the console and let's take the EC2 instance. This is the one which you create now, right? So go here, go to security. IAM role is empty now, right? Action, security, modify IAM role, and we can use IAM role called ECR full access. Now select the EC2 and go to security. You can able to see the IAM role is matched. So which means this EC2 has a full access to create Elastic Container Registry. So how we are going to create now? Let's see. AWS configure should be run. So that is one of the important reasons. So it will fail. The reason is AWS config needs to be configured, but I will do that later. Let's do, now we have created an Elastic Container Registry. So click here and see whether is it created here. Yes, we can able to see the Elastic Container Registry is created. So let's go back and see the command. So AWS ECR create repository. The repository name is Hello Multicloud 4 repository in the region US West 2. See here, Hello Multicloud 4 registry. Now everything is simple. So just click here, view push command. How we are going to push the image? We do have the complete command here. So copy, do paste here. We do have a permission issue. The reason is I have to create one more session. I have to log out and log in, or else we can use sudo. Let me open a duplicate session. I hope you can able to see my screen still. See here, now we pushed the image to Elastic Container Registry. Let me open one more new session to show that. We were creating only the empty repository, and now the images will be pushed here. So now there is no image, right? So go back. And do the Docker build. Docker build is already completed in our case. Now let's take the command here, and here where the tricky part is. Okay, the login password part is already completed. Let's do the push. So the images is in our EC2 machine, and what we are going to do is we're just going to push the image before pushing the image. It needs to be tagged, so the tag is missing, so that is what the error we are getting. And don't worry, I'm going to send you all the commands. I'm in progress of creating the blog, so just follow me in LinkedIn. I will send you, or else I can send to Gavaskar, and even he can able to share with you all. So now the push is in progress. The image from our EC2 machine is getting pushed into the Elastic Container Registry. We created one ECR and we pushed the image. Now, let's go back to the console and see whether image is created. So there is no image. And now refresh and see the image is getting pushed from our EC2. So far we have completed this part and this part. Now the very important part, what we're going to see is AWS Fargate. The next step is Fargate ECS cluster creation. So we just type Fargate here. Are we going to see any service like that? No. Fargate is a technology. Okay, I'm repeating. Fargate is a technology that you can use with ECS or EKS to run your container. So we can even say Fargate is serverless, Fargate is container. So both are correct. So you have to click Elastic Container Service or Elastic Kubernetes Service. Here we are going to see Elastic Container Service. Go ahead and click here. And I have already created a couple of clusters. Let me create a new cluster, okay? So just click a cluster if you see for use with either AWS Fargate. So there is three options to create clusters. So one for the Linux Army and one for the Windows Army. Here we are going to use serverless Fargate, right? So as here mentioned, for use either with AWS Fargate, so just click here, network only, and click the next step and provide some name here. So let's take a name called Multicloud Demo 1. That's it. So we don't need to provide any other information. The cluster is created so within a second. So when you click it, so the cluster is ready. The next step is create the task definition. So what is task definition? If you see it, so there is nothing here under service, there is nothing here under task, there's nothing here under ECS instance. So when you create manually, you will see the EC2 machine here, but we are going to use Fargate. You will see the task, which means whatever the image you have created, your application will be run here as the ECS container, right? It will be show as under the task. So that is what we are going to see here. So which means whatever the container will up and running, the application will be run under here as a task. So go to task definition. Task definition is literally a template. So what is template? So we are going to see. So click the Fargate as a next step. So provide some meaningful name. Multicloud for you. Task definition. Task role by default, you can even leave it. It will not create any impact. Operating system family also you can leave it, or you can choose Linux because we have selected Ubuntu, right? And the memory. See here, you are going to create a container. That container needs some memory and vCPU and all, right? So one container will have how much memory and how much vCPU can be allocated. See here, maximum 30 GB memory can be allocated, which means the application can handle within 30 GB. Definitely you can use containers. And the CPU also, maximum 4 vCPU, you can use it. And I'm going to use very minimum to avoid multiple cost here. So just click add container, and you are going to add the container what we have created. Maybe we can, there is multiple names to remember, so don't worry. So just remember the architecture and go with the flow. So multi-cloud for you, container demo. Maybe I'll name like this. Here it's asking image. So where is the image? So just remember, we have our image already pushed into ECR. We have to take the image name URI from here. Go back to ECR. Okay. And click latest. Under that, you see something called URI. So this is your image URI. Okay. And paste the image name here. And most of the things we can leave as it is. So memory, I could see 128 is minimum, and let me select that. And port number, I'm going to use the default port number. So the container port number is also 20. Okay, so here the container port number 20, the port number which I'm accessing, that is also, I'm sorry, 80. So here also 80, and the one which I'm going to access from browser, that is also 80. Actually, the host port can be supported different port number, but just for easy remember, I'm going to use port number 80. I'm not getting the next page, so that's why I'm minimizing the font. So excuse me. So everything is default. I'm just clicking tab, tab, tab. I'm not changing anything. Okay, so I'm not changing any other values. I'm just clicking add here. Network mode is continuing the task which are the ENA. Okay, that shouldn't be any problem. Let's click here and check it once again if everything is good. Image. Standard, everything is good. We're not changing anything or leaving everything as default. That's okay. So container is good. We have already added. And go down. It's already mentioned it's a template, which means template in the sense how many containers, what is the CPU, and what is the RAM, everything we are mentioning here in the template. So we're just creating the task definition here. A multi-cloud for 0 to 2 completed. There is something wrong. Let's go and check. AWS VPC, Linux, task definition 0.25, add containers are completed. Enable app, we don't need anything. Yes, now it's completed. I don't know why, so we didn't do anything. So task definition is ready. It's a template. Now, even still, if you go back to a multi-cloud demo one, we don't see any task up and running, right? Now, our template is ready. So based on the template, we are going to create the task. Okay, that is your typical application. Run new task, select Fargate, operating system family Linux. And if you see the task definition, the multi-cloud 4 is the one, the template which you created now. Platform version, I'm leaving as default. I'm not changing anything. So cluster, the number of tasks. So this is the one you have to remember. For example, here it shows number 1, which means only one instance will get created. If I mention 50 here, 50 containers will get created. For example, you have the Flipkart day and you have the Amazon day and all, right? So during the day, they will open their application, the URL or the huge offers by 9 a.m. or 8 a.m., right? That time they do pre-warm and they do have the applications ready in multiple numbers. So the pre-warm is a different concept. So maybe we'll discuss that, I mean, sometime later. So the number of tasks we can mention here, but I'm just leaving as 1. So cluster VPC, use the default, and subnet also we can use maybe 2 A's, 1 is enough, or maybe we can even mention 2 subnets. Anyway, I'm just mentioning 1. So only 1 will get created now. Security group. There's a lot of security groups. We need to be more careful. So just click 8 and see the port 80 is allowed anyway. Sounds good. Then you can click cancel. I'm leaving everything by default and click run task. Let's see. So the task is created and it's in provisioning state now. Do refresh and see. Now it's pending state. It has to come to running state. If it is not coming to running state, then there is some issue. It's running. Sounds good. So click the task, which means one of your tasks, either this one or this one, is created. See here, you have the public IP. Once you clicked it, so take the public IP, Control C, open new tab, boom. You have the URL. Your application is up and running as a container now. So as a scenario 1, we created image, we tested the URL. So scenario 2, we pushed into ECR. From ECR, we created a Fargate. Fargate is pushed the image from ECR and we created a container here and it's up and running. Got it? Now, so time check, we do have 10 more minutes. Let's see whether we can able to cover Amazon load balancer part. So the next one is we have to create Amazon load balancer and we have to create target for that. And it can, the next hop for the Amazon target is Fargate services. So the target cannot able to communicate directly to either task or something. So we have to create something called service. If you see service, now we have one task up and running, right? Under service, now it's blank because we have to create a service, or else the Amazon load balancer will not be able to communicate. So the flow will work fine only if you create service. So the next step is go to ALB. Load balancer, EC2 feature, Click open link in new tab. Make sure, it will cost something around $12 whenever you create load balancer. Create load balancer, application load balancer. Click create. Maybe I can name it as multi-cloud for you, and it's internet facing IP address, default VPC. Maybe I can choose A and B. Security group. I could see default security group is already mapped. And port number 80 is already configured. And here, create target group. Yes, that is, we should create now. So elastic load balancer, maybe flow, you can think like this, ELB, and it has to map with the specific target group, and target group will come to service. Go back to the architecture. Amazon load balancer, so target group to be created, and target group will be mapped with service. It's Fargate service, ECS here, okay? So here we have to choose IP address. So make sure we have to choose only IP address because we are creating the container. So containers is be configured as IP address. If you choose instances, it will be really difficult. It will not work. So target group name, multi-cloud, target group, HTTP 80, and I'm going to leave everything by default. Health check. I'm leaving everything default. Let's see. Register targets. That we can do, we have to do later, I guess, but let's see. Now, this point of time, default, specify the IP address. We don't have the IP address now. Go back here. Without that, we will not be able to map. Let's see. Add-on surveys, global accelerated tags, and everything we're going to leave as default. Let's click load balancer. Let's see whether no. Go back and leave the IP address by default. VPC port number is 80. Review targets. Okay, we have created something called multi-cloud target group. Refresh here. So click here. You see that the target group. Now you can able to create load balancer. It will take few minutes for the load balancer to be created. Now let's go back and let's create a ECS service. Go to service, create, click Fargate, Linux, the task definition, everything. We have only one, leave everything as default. Cluster names, multi-cloud demo 1, multi-cloud 4, task definition, service name, multi-cloud service. Number of tasks, just mention maybe maximum 2, so don't go more than, which means 2 containers will get created. If you mention 50 containers will be created. It's so expensive because it's a pay as you go. Rolling update, I'm not changing anything. Go to next step. Cluster VPC, choose the default one. Subnet, choose the 2A, and since you mentioned 2 tasks, we can mention 2 subnet, which means go back to the diagram, 2 subnet, right? So we are mentioning 2 here. Security group, maybe we'll leave as it is, but there is one change needs to be done that we will do it later. None. Load balancer type, we have to select application load balancer. Let's see whether our load balancer is created. Still in provisioning state. Let's do refresh. Active. Should be good. Let's see. Select application load balancer, and load balancer name is multi-cloud for you. By default, it has come. And container name, port number, you have to click here without fail. And The listener port number is 80. HTTP create new. Sounds good. Already exist. Choose it. Target group name. Leave everything by default. I'm not touching anything. Let's go to next step. Path pattern evaluation order. Doesn't match another rule. You can later add additional patterns and let's see. Go to next step. Just quickly recheck Fargate replica to. We're not changing anything. Let's create service. Okay, I could see everything is green. Let's click view service. Okay, service is active and auto as an IP is enabled. Go to task. We have mentioned two tasks, right? So one is in provisioning and one is pending. I could see one is running and one is pending. So there is one more configurations we have to do. So the load balancer, we need to provide access to load balancer here, or else we will not be able to access. Let's see. Listeners are good. Description is good. Go back and slowly check all the configurations. I really have a doubt here in security group. Let's check the URL and then we'll go for a troubleshooting. So clear. So take the DNS name. We provided the name called Multicloud for you. So now the load balancer is created and let's go here, paste the URL. Boom. Fantastic. So we can able to complete all the scenarios. I'm going back to the architecture diagram. I'm repeating the three scenarios which we did. We created EC2, we installed a Docker, we created an image, and we access the direct URL from here, from browser. So step number 2, we pushed the Docker image to Elastic Container Registry. We created a Fargate. We pulled the image from Elastic Container Registry and we created a task, the template we created and the container, and we hit the URL directly, which means the admin directly hit the URL. That is also working. Now the third scenario, we created a load balancer. From the load balancer, we created a service, we created a target group here. So target group to service, the third flow, that is also working fine now, which means all the general users, if you use the URL from internet, everyone can able to access. Now I'm coming back to my presentation. But don't worry, there is a lot of steps are involved. So there is a lot of security groups has to be created. So a lot of names to be remembered, but I'm going to create a detailed blog for this. So once the architecture completed, it's a on AWS certifications. What are the certifications you can do, and where should I start? Of course, you do have Amazon.com, and there is a course called Cantrell, and there is a lot of courses in Udemy, Cloud Guru. So one of our author Chandralingam, he is also good. So Cantrell is also really good. So you do have a lot of pictorial emojis. You can buy any course and you can start your learning. Certification or learning strategy. So keep your learning alive and you have to come up with a strategy. For example, every day we have to spend minimum 1 to 2 hours. I'm working in some other domain. I mean, how do I move to cloud technology? So you have to show your interest to your management by completing some certifications. Ask for some other project. If possible, you can move to some other project or you ask additional work. For example, your day-to-day work is 10 hours. You have to spend 2 to 3 hours as additional to improve your knowledge. So that's one step. If you do that, of course, you can able to plan and strategies. I mean, so whenever your brain is feeling tired, you can take some 10-minute nap or take a deep breath or some meditation for 7 minutes. So the strategies is not common for everyone. Everyone has to come, so each one of you has to come up with your own learning strategy. Finally, so this is my LinkedIn profile. Let me ping my LinkedIn profile to you all. I'd like to connect with you, and definitely we'll be in touch for any future programs and post. I'm trying to find the chat, guys. So bear with me. Yeah, found it. So it's my LinkedIn profile. That's it. So thanks everyone. It's a Saturday night. I really thank you everyone to extend your weekend.
So really, on behalf of Multicloud for you, we like to thank Arun Kumar. It's an excellent session on how to deploy application by using AWS Fargate. Thank you all the participants, and once again we like to thank Arun Kumar for giving an excellent session on containerization using AWS Fargate. Thank you once again, Arun Kumar.
Thanks so much, Gavaskar.
Have a nice day. Have a nice day.
You have a good weekend all.